So the next topic summary, transaction isolation. Right. So you all know that a transaction processing system allows multiple transactions to run concurrently. Right. So multiple concurrent execution of multiple transactions leads to several complications with inconsistency of the data. Right. However, there are two good reasons for allowing the concurrency. Right. So the next chapter is about concurrency control. So the idea is that right. So you don't have problems or issues once you are going to execute the transactions serially one after the other. Right. So however, in real time we allow concurrent execution of the transactions. Right. So multiple users will be paying their tuition fees to the university. Right. So similarly, the university may have many creditors who will be clearing the bills. Right. They will be presenting their bills to the bank, and multiple vendors they will be getting their money from the institute simultaneously. Right. So in order to improve the throughput of the system, right? So we allow concurrent execution of the transaction. Right. So allowing multiple transactions to update data concurrently causes several complications with the consistency of the data. So that we'll discuss in today's class. Right. So however, there are two good reasons for allowing the concurrency. So concurrency means you are going to execute two or more transactions concurrently in the same environment. Right. So you all know the isolation property, right? So for a pair of transactions TA and TJ, right, I have a call. 1 minute, I will be back. Right. So why do we go for a concurrent execution of the transactions? Right. So what do you mean by so we have studied isolation property, right? So for a pair of transactions TA and TJ that are running concurrently, it appears to transaction TI that TJ has already completed its execution, or transaction TJ will start its execution only after TA completes its execution. It's known as isolation property, right? So each transaction is unaware of the other concurrent transactions that are being executed in a system, right? So what's the advantage of this concurrent execution is that improved throughput and resource utilization, right? So you all know that a transaction may contain many steps. So some involve IO activity and others involve CPU activity, right? So the CPU and IO operations can be performed in parallel, right? So if you have one transaction is performing IO activity, the other transaction can be performing CPU activity, right? So this increases the throughput of the system, right? So throughput means the number of transactions that are being executed in a given amount of time, right? So whenever you need to go for some improved performance, so improved performance means you are going to increase the number of transactions that are executed per unit time, right? So the university would like to have multiple concurrent transactions so that multiple users will be able to pay the tuition fees, right? Similarly, if you look into the resource utilization, right? So generally, if you are going to allow it, if you are going to schedule the transaction serially one after another, what happens is that the resource utilization may not be very good, right? So here, whenever one transaction is executing CPU time, the other transaction can execute its IO time, right? So there's an improved resource resource utilization, right? So this is the advantage of concurrent execution of transactions, right? So the second advantage is that reduce the waiting time for many transactions. So what happens is that generally you have a mix of transactions, right, running on a system. So some transactions may require short time, whereas the other may require a long time, right? So you have a mix of transactions. Some transactions may require only a short time for its completion, whereas some other transactions may require a very long time for completion, right? So if transactions are running serially, what happens is that transactions are running serially one after another. A short transaction has to wait for a preceding long transaction to complete, which may lead to unpredictable delay in running a transaction, right? So generally we have a mix of transactions, short transactions and long transactions. Short transactions may consume less CPU time and IO time, whereas long transaction they may need more CPU time and IO time, right? So if you are allowing the transactions to execute serially one after another, a short transaction may have to wait for the longer transaction to complete, right? So which may lead to unpredictable delays in running a transaction, right? So however, if the transactions are operating on different parts of the database, it is better to let them run concurrently, sharing the CPU cycles and disk access among them, right? So you are going to have two different transactions running on different parts of the database. It is better to allow multiple concurrent transactions which can share the CPU cycles and disk access time, right? Right. So in today's class, we'll see a simple example, a simplified banking system. We'll study what are the issues in concurrent transactions. So first, let us consider a simplified banking system, which has several accounts and a set of transactions that access and update these accounts, right? So we are going to have a very simple transaction T1 and T2, right? So transaction T1 is going to transfer $50 from account A to B, right? So it's quite simple, right? So T1 you are going to debit $50 from account A and you are going to credit the amount into account B, right? And you have another transaction which transfers 10% of account A to account B, right? So 10% of account A is being calculated and it's stored in a variable term, right? So this 10% of the amount is being transferred from account A to account B, right? So let us assume that the initial values of accounts A and B are going to be $1,000 and $2,000 respectively, right? So suppose that two transactions are executed in the same time. The order T1 by followed by T1, right? So this execution sequence is known as serial schedule, right? So for example, let us visualize serial and concurrent transactions in today's class. So we'll see an example for serial and concurrent transactions. So the first transaction T1 is going to debit $50 from account A and it is going to credit $50 onto account B. The second transaction T2 is going to find 10% of account A and it's going to debit 10% of account A, storing in a variable term, right? And it is going to add it, credit it to account B, right? So the initial values of the transactions, the initial values of account A and B are going to be $1,000 and $2,000 respectively. Now we are going to execute the transactions as serially, one after another, right? So now I want you to get me the values for the variables A and B the process of this transaction. Right. So what's the initial value of A and initial value of B? The initial values of accounts A and B are $1,000 and $2,000 respectively. Now first let us run the transaction serially T1 followed by T2. Right. So let me ask someone to work this and update me. Hemant.
Yes, sir.
So can you find out what is the values of accounts A and B during the execution of this transaction?
Yes, sir. So after the first transaction, account A will have 950 and account B will have 2050.
Correct. Then
Yes, sir. So after
so
the
T1 is executed. Right.
yes,
T1 is executed followed by T2 serially. Right.
yes, sir. So after the second one, we'll
So what's the
have
value of 10? 10 value is going to be
yes, sir. Just a minute. And temp value is 95.
correct. Then
And the account A's balance will be 855.
correct. Then
And account B's value will be 2145.
right. So the values of accounts A and B after the serial execution of the transaction is going to be $845 and
Yes,
$2145 respectively. And the initial values are going to be $1,000 and $2,000
2000.
respectively. Right. So put together $3,000. Right.
Yes, sir.
Hemant, so does it meet the requirements of consistency property of your database?
Yes, sir. The sum is the same.
Right. So the sum of accounts A and B before the transaction and after the transaction are going to be same. Right. So
Same.
initially the values of accounts A and B are going to be $3,000. $1,000 plus $2,000. So it's going to be $3,000. After the
Yes.
execution of the transactions T1 followed by T2 serially, the values of accounts A and B are going to be $855 and $2145 respectively. So the sum of accounts A and B is the same before and after the execution of the transaction. Hence, consistency properties preserved here. Right, right, payment. Right. So the final values of accounts A and B are going to be $855 and $2145 respectively. Right. So the total amount is going to be same before and after the end of the transaction. Right. So the consistency property is preserved during the transaction. Right. So now let us execute the transaction T2 followed by T1. Right. So now again what we are doing, initially we were executing a serial schedule where we were executing the transaction T1 followed by T2. Now we are going to execute again a serial schedule where we are going to execute T2 followed by T1. Right. So here the transaction T2 is going to run. It's going to debit 10% of account A stored in a variable temp. Right. You are going to debit 10% of values from account A and you are going to credit it into account B. And then followed by another transaction which transfers $50 from account A to account B. Right. So this I want one of you to work out and get
So it'll
me
be the
the
same in the end, sir.
so
So it'll
right. So what's your name?
Vishwanathan, sir.
Nishant. Huh?
Vishwanathan, sir.
Vishwanathan.
Yes.
Correct Vishwanathan.
So
Vishwanathan, can you
after
get me the
T2,
intermediate steps? Like we are
yes, after
interested in the
T2 it will be
intermediate.
900 and 2100 because 10% is 100 from 1000. So we'll subtract 100 from 1000 will be 900.
Right.
And we'll add 100 to B, so that'll be 2100.
Right. So after the end of transaction T1, it will be 900 plus the account A will be 900
Yeah,
and
and
account
account
B
B will
will
be
be
2000.
2100. Right. Then followed by transaction T1. What happens? What's the value of intermediate values of accounts
Subtract
A and B?
50. We'll subtract 50, so it will become 850, and the account B will be 2150.
Right. So again, what's going to be the sum of the accounts A and B after the end of the transaction?
3,000.
3,000. So what's the conclusion?
It's still consistent, sir.
Right, it's still consistent. So the idea is that it's easy to prove that when the transactions are being executed serially, one after another, it leads to a consistent state. Right. So T1 followed by T2 or T2 followed by T1 doesn't make any difference. So whenever the transactions are executed serially, it results in a consistent state of a database. So, like as Viswanathan has pointed out, if the transactions are executed one at a time serially, point is that it is executed serially, T2 followed by T1. The corresponding execution sequence is given in the previous slide, figure 14.3. Again, the sum A plus B is preserved. The final values of A and B are going to be $850 and $2150 respectively. However, money is not created or destroyed during this process of transaction. Its consistency is preserved. Right. So next